Picture this: a silent void stretching endlessly beyond the stars, where nothing stirs for millions of years. Then, out of that darkness, something moves. A faint flicker, a shadow against the cosmic backdrop, racing toward our solar system. It's July 1st, 2025, and NASA's telescopes catch it, a wanderer from beyond, the third interstellar visitor humanity has ever seen. This isn't just another rock drifting through space. This is something different, something that doesn't belong. And within hours, NASA does something unthinkable. They try to talk to it. Imagine the weight of that moment, humanity reaching out to the unknown, like knocking on a door in the middle of nowhere. But what if something knocked back? What if the universe answered in a way we weren't ready for? This isn't a movie. This is real. And it's the story of an emergency that shook the world's greatest scientists and left us all wondering, are we truly alone? Let's step into that moment. It's early July, and NASA's ATLAS survey, a network of telescopes scanning the skies for anything unusual, picks up a fast-moving object. They name it 3I/ATLAS, a designation that marks it as only the third confirmed visitor from beyond our solar system. For perspective, our sun and its planets are just a tiny speck in the vastness of space. This object? It's been traveling through the emptiness between stars for millions, maybe billions, of years. It's not on a collision course with Earth. NASA confirms it'll pass safely at 1.6 astronomical units, about 150 million miles away, well beyond Mars. No threat, no danger. Just a cosmic traveler passing through. But here's where things get strange. Most comets or asteroids get cataloged, studied slowly, debated over months. Not this time. Within 24 hours, NASA's not just watching, they're acting, and they're acting fast. What do you do when you spot something that doesn't belong? You investigate. And NASA doesn't mess around. They swing into action with their most powerful tools, like a team of explorers shining a flashlight into the dark. First up, the Deep Space Network. Picture massive 70-meter radio dishes, think football fields of steel, stationed in California, Spain, and Australia. These are the same dishes that talk to spacecraft as far away as Pluto, sending signals across billions of miles with pinpoint accuracy. This time, though, they're not talking to one of our probes. They're aiming at this mysterious object, sending focused radio waves to see what it's made of, how it moves, what it's doing. Then there's the Goldstone Solar System radar, a beast that can bounce radio waves off asteroids 20 million kilometers away and map their surfaces in stunning detail. NASA fires its most powerful pulse at 3I/ATLAS, expecting to learn its size, shape, and composition. And for the first time, they deploy their newest trick, optical laser communication, a system they tested in 2023 to send laser signals across vast distances. If this object has any reflective surfaces, a laser could reveal secrets invisible to radar. Why go to all this trouble? Why not just watch it pass like they did with Oumuamua in 2017 or Comet Borisov in 2019? Because something about this object feels different. It's like hearing a knock at your door in the middle of the night. You don't just ignore it. For decades, NASA's been humanity's way of knocking on the universe's door, sending signals, listening, waiting. But this time, they're not just listening. They're shouting into the void, hoping for an answer. And what comes back sends a shiver through the control rooms. The radar echo from Goldstone doesn't behave like it should. If this were a typical comet, a ball of ice and rock, the echo would be clean, predictable, like a ball bouncing off a wall. But this? It's off. The frequency shifts in a way that doesn't match any comet NASA's ever studied. It's as if the object has something inside it. Maybe internal structures, maybe metallic components, maybe something we've never seen before. Scientists stare at their screens, double-checking the data, their hearts racing. This isn't supposed to happen. Now picture the control room. It's late, the coffee's cold, and the air is thick with tension. NASA's not just dealing with telescopes and radar. They've got their most advanced artificial intelligence systems on the case. These are the same algorithms that sift through terabytes of data from the James Webb Space Telescope, spotting patterns no human could catch. They're trained to find the tiniest hints of order in the chaos of space, pulsars, galaxies, even the rings of Saturn. But when they analyze the signals from 3I/ATLAS, they find something that makes the room go quiet. The AI flags non-random pulses, repeating sequences, patterns that follow mathematical progressions. This isn't the chaotic static you'd expect from a comet heating up near the sun. It's structured, rhythmic, like a faint drumbeat in the dark. Imagine tuning an old radio, wading through static, and suddenly hearing Morse code. That's what the AI picks up. Something that feels designed, not natural. The scientists cross-reference these patterns against every known cosmic phenomenon. Solar wind? No match. Magnetic fields? Nothing. Plasma resonances? Still no fit. The AI's seen it all before. Except this. It's outside its training data, a discovery so unusual it sends a chill through everyone in the room. Because when your most advanced tech can't explain what it's seeing, you're either on the edge of a breakthrough or staring at something that changes everything. This isn't just a comet anymore. It's a question mark, a mystery that demands answers. And it's why NASA doesn't wait. They don't follow their usual playbook of slow, careful study. Within hours, they call an emergency briefing, unscheduled, urgent, pulling in senior officials during off hours. International space agencies get alerts through channels usually reserved for imminent threats like an asteroid on a collision course. This isn't normal, this is something big. But let's pause here because there's a bigger picture taking shape. This moment, this object, this response, it's not just about what's happening now. It's about what's happened before. The universe has been dropping hints for decades, and NASA's been chasing them, piecing together a puzzle most of us don't even know exists. Back in 1977, a radio telescope in Ohio caught a signal so powerful, so structured, it lasted 72 seconds and left the astronomer who found it scribbling "wow" in the margins. It came from Sagittarius, and 47 years later, no one's explained it. Then, in 1991, a strange object called 1991 VG appeared in an Earth-like orbit, moving in ways that didn't add up. Its strange reflective surfaces and rotation didn't match any known spacecraft, and no space agency claimed it. Fast forward to 2017, and Oumuamua, the first interstellar visitor, races through our system, speeding up as it leaves without any visible comet tail. Scientists at Harvard suggested it might be artificial. NASA said it was invisible gas, but no other comet's ever done that. Even the Voyager probes, out at the edge of our solar system, hit mysterious data dropouts, brushed off as glitches but timed too perfectly to feel random. These aren't isolated stories. They're threads in a tapestry, moments when the universe seemed to whisper something we couldn't quite hear. And now, with 3I/ATLAS, it's whispering again. Louder, clearer, closer. NASA's reaction tells us they're hearing it too. They're not just studying a comet, they're chasing a possibility, a chance that this object holds secrets we're only beginning to grasp. And as the data pours in, as the AI keeps flagging patterns that don't belong, one question burns brighter than ever. What if this isn't just a rock? What if it's something more? Something that could rewrite everything we thought we knew about our place in the cosmos? The room is buzzing now, screens glowing with data that doesn't make sense. Scientists lean over consoles, their voices low but urgent as the numbers keep rolling in. It's July 1st, 2025, and NASA's just tried to talk to an interstellar object. 3I/ATLAS, a cosmic drifter from beyond our stars. They sent radio waves, radar pulses, even laser signals, expecting a simple echo from a chunk of ice and rock. But what came back wasn't simple. It wasn't expected. The radar echo shifted in ways that defy what we know about comets. The AI systems built to spot patterns in the chaos of space flagged something impossible. Structured pulses, repeating sequences, rhythms that feel like they were meant to be heard. This isn't just a comet anymore, it's a mystery, and it's pulling NASA into uncharted territory. The question isn't just what this object is, it's what it means. And as the hours tick by, the stakes keep climbing. Let's zoom in on that moment when everything changed. The Goldstone Solar System radar, a machine so powerful it can map an asteroid's surface from 20 million kilometers away, sent its pulse toward 3I/ATLAS. Scientists expected a clean bounce, the kind you get from a frozen comet nucleus: ice, rock, maybe some dust. But the echo came back wrong. The frequency shifted, not randomly, but in a way that hints at something inside the object. Maybe complex structures, maybe metallic surfaces, maybe something we've never seen in nature. NASA's Deep Space Network, those massive dishes in California, Spain, and Australia, picked up faint radio emissions from the object itself. And here's where it gets eerie. The AI analyzing those signals found patterns that don't belong. Not the chaotic hiss of a comet heating up near the sun, but something deliberate: pulses at regular intervals, sequences that follow mathematical rules. It's like hearing a heartbeat in the static, steady, and unnatural. These AI systems aren't new to this game. They're the same ones NASA uses to decode the universe's secrets, sifting through terabytes of data from the James Webb Space Telescope. They've found pulsars spinning in distant galaxies, mapped the rings of Saturn, classified stars by the faintest flickers of light. But this is different. The algorithms cross-check these patterns against every known cosmic phenomenon: solar wind, magnetic fields, plasma waves, and came up empty. Nothing in their vast database of stars, comets, or asteroids matches what they're seeing. It's as if the object is speaking a language the AI wasn't trained to understand. Imagine the chill that runs through the room when the screens light up with those results. Scientists, some with decades of experience, stare at each other, unsure whether to trust their own eyes. Because if this is real, it's not just a discovery, it's a turning point. That's when NASA makes a call they've never made before. They don't wait for weeks of analysis or peer-reviewed papers like they did with Oumuamua, the interstellar visitor that puzzled the world in 2017. They don't sit on the data for months debating theories. Within hours, they convene an emergency briefing. This isn't a scheduled press conference or a routine update. Senior officials are pulled in during the middle of the night. International space agencies like ESA in Europe and JAXA in Japan receive urgent alerts through channels usually reserved for something catastrophic, like an asteroid on a collision course with Earth. The urgency alone tells us something's wrong. NASA's studied thousands of comets and asteroids over decades, with protocols for everything: tracking orbits, measuring compositions, predicting paths. But 3I/ATLAS breaks the mold. It's moving too fast, revealing too much, raising questions they can't answer yet. And here's where the story takes a darker turn. This isn't just about science anymore, it's about security. The moment NASA detected this object, U.S. Space Command was notified. That's not a conspiracy, it's standard protocol. Any unidentified object entering our solar system triggers an alert to military space surveillance networks. Space Force, created in 2019, has been quietly building rapid response systems for exactly this kind of scenario. Satellites and probes ready to launch within hours if something unknown shows up. The Pentagon's Advanced Research Division, DARPA, runs classified programs to study potential dual-use technologies in space. If 3I/ATLAS showed even a hint of being artificial, it wouldn't just be a scientific curiosity, it would be a national security priority. Imagine the possibilities. A probe from another star system carrying technology we can't even dream of. Reverse engineering it could change our world overnight. New energy sources, new materials, new ways to explore the cosmos. But there's a flip side, a shadow that looms larger. What if it's not just passing through? What if it's watching us, gathering data on our planet, our defenses, our technology? These aren't wild theories, they're questions the military has been asking for years. Space analysts have run simulations, wargaming what happens if an advanced civilization sends reconnaissance probes to other star systems. How would we spot them? How would we respond? The signals we sent to 3I/ATLAS, radio waves, radar, lasers, are proof we're advanced enough to notice. But they're also a signal to whatever's out there that we're here, watching back. And if this object is more than a comet, if those structured pulses are a response, then NASA's contact attempt might have been the first test of humanity's readiness. The emergency briefing wasn't just about sharing data with scientists. It was about coordinating with governments, space agencies, maybe even military leaders, preparing for something they can't yet explain. Now, let's step back and look at the bigger picture, because this moment doesn't exist in a vacuum. The universe has been dropping clues for decades, and each one feels like a piece of a puzzle we're only starting to understand. Think back to August 15, 1977, when a radio telescope in Ohio picked up a signal so strong, so structured, it lasted exactly 72 seconds. It came from the direction of Sagittarius, and the astronomer who found it wrote, "Wow," in red ink, a moment that's echoed through history. NASA and SETI have spent 47 years trying to explain it, debunk it, or recreate it, and they've got nothing. Then, in 1991, an object called 1991 VG appeared, orbiting too perfectly, too close to Earth's path. Its strange reflective surfaces and rotation didn't match any known spacecraft, and no one claimed it. In 2017, Oumuamua raced through our system, speeding up as it left without any visible comet tail. Harvard's Avi Loeb suggested it could be artificial. NASA chalked it up to invisible gas, but no other comets ever behaved like that. Even our Voyager probes, pushing past the edge of our solar system, hit mysterious data glitches right as they crossed into interstellar space, dismissed as equipment failures. But the timing feels too perfect. These moments aren't random. They're whispers from the cosmos, hints that something's out there, something we're not ready to fully grasp. And now, with 3I/ATLAS, the whispers getting louder. The patterns in those signals, the urgency of NASA's response, the involvement of military channels, it all points to a truth we're only beginning to touch. This object, this fleeting visitor, might be the key to unlocking a question humanity's been asking for centuries. Are we alone? Or is the universe watching, waiting for us to catch up? The stars have always felt like a distant dream, a canvas of light we gaze at but never truly touch. But now, in the summer of 2025, something's changed. NASA's reached out to an interstellar visitor, 3I/ATLAS, a mysterious object from beyond our solar system, and the response has left them reeling. Structured pulses, rhythmic patterns, signals that don't match any natural comet. An emergency briefing, called in the dead of night, pulls in scientists, government officials, even military leaders. This isn't just about a rock in space anymore. It's about what it could mean for us, for humanity, for our place in the vast unknown. The question isn't just what this object is, it's whether we're ready for what it might reveal. Because the truth, whatever it is, could change everything. Let's pull back the curtain on the science for a moment, because there's a strange paradox at the heart of this story. On one hand, NASA's public data paints a clear picture. The Hubble and James Webb Space Telescopes have captured images of 3I/ATLAS, showing exactly what you'd expect from a comet. A bright nucleus, a glowing coma of gas and dust, a tail streaming away as it heats up near the sun. Spectroscopic analysis confirms it's made of water ice, carbon dioxide, and rocky debris, textbook comet material. Its brightness shifts match the rotation of an irregularly shaped nucleus, and its path follows the predictable arc of gravitational physics. Compared to past interstellar visitors like Oumuamua in 2017 or Comet Borisov in 2019, it checks every box for a natural object. No exotic materials, no wild anomalies in its trajectory. Just a comet passing through at 1.6 astronomical units, about 150 million miles from Earth, no threat to anyone. So why the panic? Why the urgent briefing? Why did NASA act like this was anything but routine? The answer lies in what they did, not just what they saw. NASA didn't just observe this object, they tried to talk to it. They aimed their deep space network's massive radio dishes, fired pulses from the Goldstone radar, and even sent laser signals, a technology they perfected in 2023 for deep space communication. This wasn't passive study. It was an active outreach, a bold step into the unknown. And when those signals came back, shifted, structured, unlike anything a comet should produce, NASA didn't follow their usual playbook. They didn't wait for months of peer review or debate. They called in the big guns, fast. That speed, that urgency, tells us something's off. It's as if they saw something in those patterns, those AI-flagged sequences, that made them question everything. Something that made them wonder, is this really just a comet, or is it something more? Now let's step into the bigger picture, because this moment feels like part of a larger story, one that stretches back decades and hints at a universe that's been trying to get our attention. Think about the WOW signal from 1977, a 72-second burst of structured energy from Sagittarius that's never been explained. Or 1991 VG, that strange object in an Earth-like orbit, reflecting light in ways no known spacecraft could. Then there's Oumuamua, speeding up as it left our system with no visible gas to explain it, sparking wild theories from Harvard about artificial origins. Even the Voyager probes, humanity's farthest explorers, hit unexplained glitches right as they crossed the edge of our solar system. These aren't just random events. They're pieces of a puzzle, moments when the cosmos seemed to nudge us, daring us to look closer. And now, with 3 I/ATLAS, that nudge feels like a push. Here's where it gets haunting. What if these objects aren't random at all? What if they're part of something bigger, something intentional? Imagine a civilization out there, far beyond our reach, sending probes to study emerging worlds like ours. They design them to blend in, looking like comets, acting like rocks, to avoid sparking panic. These probes would watch, listen, gather data on our technology, our defenses, our readiness. And when we sent signals to 3 I/ATLAS, radio waves, radar, lasers, we might have passed a test. Our outreach could be proof that we're advanced enough to notice, bold enough to try. Those structured pulses, those rhythmic signals the AI flagged, they might be the universe's way of saying, "We see you too." It's a thought that sends chills down your spine, not because it's certain, but because it's possible. And here's the kicker. If NASA did get a response, a real one, would they tell us? Think about it. Confirming that an interstellar object answered back would shake the foundations of everything we know. It would raise questions about intelligence, technology, our place in the universe, questions we might not be ready to face. NASA's always played it safe, taking months to verify data, years to announce big claims. They spent years analyzing Oumuamua's odd acceleration, debating Comet Borisov's makeup. If 3 I/ATLAS is something more, they'd hold it close, sharing only with trusted agencies, maybe even military partners like U.S. Space Command or Space Force. The Pentagon's already involved, standard protocol for unidentified objects in our system. They've got rapid response systems, classified programs through DARPA, ready to analyze anything that might be tech from another star. The stakes are too high for them to rush to the public with half-formed answers. This brings us to the heart of it all, the question that lingers long after the briefing ends. What does this mean for us? For the first time in history, we've reached out to an interstellar visitor, and something unexpected came back. Whether it's a comet with strange properties or something far more profound, this moment marks a shift. We're not just watching the stars anymore, we're shouting into the void, and the void might be listening. As 3 I/ATLAS drifts away, heading back to the darkness between stars, NASA keeps tracking it. New telescopes come online every year, sharper, smarter. Our AI grows better at spotting patterns, decoding signals. The next visitor might not be so ambiguous. It might force us to face the truth about intelligence out there, about whether we're alone, about whether we've been watched all along. So, where does this leave us? Standing at a crossroads, staring into the unknown. We've taken a step, a bold one, by trying to talk to something from another star system. The response, whatever it was, has NASA rattled enough to act fast, to pull in the world's top minds, to alert those who guard our skies. This isn't just about science. It's about who we are, what we're ready for, and what happens when the universe finally answers back. Are we prepared for that conversation? Would we even recognize it? The story of 3I/ATLAS isn't over. It's a beginning, a spark that could light up everything we thought we knew about our place among the stars. And as we keep watching, keep listening, one thing's certain: the next whisper from the cosmos might not be a whisper at all. It might be a shout.